Hey, Mike from Prep Pros here, and with the March 2025 Digital SAT only a few weeks away, we're going to cover 10 types of questions that you're definitely going to see on test day. Now, after I've worked through those 4 new Blue Book tests, I'm also going to talk about some general changes that I've observed with the test that you want to be aware of as you take the test not only in March, but in the rest of 2025. And at the end of the video, I'm going to talk about some general recommendations for you, whether you're cramming, whether you're only struggling on the second harder math module, or whether you want some additional practice tests for additional resources you can use to help you get prepared as possible for test day. Now, the first thing you're going to see on your test, as you can see, is some form of tricky percent question. And there's a few things that often trip students up with these questions. So we're going to break those all down as we work through. For the positive quantities A, B, and C, 78% of C is equivalent to 0.096% of B. When we want to solve these, we want to go from percent form to essentially number form, which means you're going to take your percent and you're going to divide it by 100 to put it in number form. So that's going to leave us with 0.78C is equal to, remember now, this is the important step that a lot of students mess up. It's not 0.096B, you need to divide that by 100. So it's going to be 0.00096. And I'm just going to make my B a capital B, because otherwise my lowercase b's often look like sixes. And we can also say that B is equivalent to 2.5A, once again dividing by 100. What percentage of C is A? Now this statement also often trips students up. They're like, am I trying to get this as C equals or A equals? If you're saying what percentage of C is A, you're ultimately trying to get this equation as A equals. But the next thing we need to do is we want to be able to substitute this in, so we just have an equation with C's and B's. So when we do that, we're going to have our 0.78C equals the 0.00096 times the 2.5A. So now we're going to just punch this into our calculator. So this is going to give us that 0.78C is equal to 0.0024A. And as we talked about earlier, we want to get this as A equals. So now we're almost done, but we'll have one final step after this. We're going to divide both sides by the 0.0024. So as we do that, that is going to leave us that 325C is equal to A. And this is the one painful place that a lot of students make a mistake. They will say, oh, it's 325. But remember, we divided everything by 100 to put it in number form. So if we want to go from number form back to percent form, we need to take our 325 and we need to multiply it by 100. And that will give us our correct final answer of 32,500. Those are the few tricky things we want to watch out for this type of question. Now, the next thing you're going to see on your test is subject-verb agreement, and this kind of is going to lead into one of my favorite digital SAT test tricks. You're going to be able to spot subject-verb agreement because you're going to see singular versus plural conjugations, like is versus are, was versus were, run versus runs, stuff like that. When you see this, you don't even actually have to read the passage to find the right answer, because there's a little flaw in how the SAT has to write these questions for them to be valid. You're either going to see 3 plural conjugations and 1 singular, or 3 singular conjugations and 1 that's plural. The odd one out is going to give away the correct answer. So we could say they were, they have been, they are. We could only say he or she is. That's where A is correct. Now, if we're looking at this more technically, the subject of the sentence can never be contained in extra information surrounded by 2 commas or within a prepositional phrase. So as we look back at this sentence, the 20th century Kashmiri American poet Agha Shahid Ali explains that each one, now this is all a prepositional phrase, of Ghazal's couplets, and now here we see commas and commas, this is all extra information. So what the SAT is going to do is put as much fluff between the subject and the verb as possible to make it harder for you to hear. But once we've deconstructed this, if we wanted to do it the technical way, we would say the 20th century Kashmiri American poet Agha Shahid Ali explains that each one, the only one that would make sense would be each one is, because our subject is singular. Those are the 2 ways we can approach this type of question, but the test trick that I talked through is super, super helpful. You can sometimes see 2 of these in the second harder reading and writing module, so it can take very complex questions and make them very easy and quick for you. Now, this next question is going to illustrate 2 things that I predict you're going to see on your test. The first is you will see some form of linear question asking you about the number type of solutions. We're going to talk about the quadratic variety later in the video. Now, the other thing that you're going to see is the SAT is really starting to play more active defense against letting you just simply graph questions in Desmos because they really want you to show that you're understanding them. So although this question is going to be very difficult to kind of do by hand and understand the right answer, we're actually going to talk about a really effective workaround we can use in Desmos, even with these variables, including the k, to still be able to find the correct answer. Now here we see one of the equations in a system of two linear equations is given, where k is a positive constant. The system has no solution. Now, what this means is if we have no solution, it essentially means we just have two parallel lines. Therefore, the slopes are going to be the same and the y-intercepts are going to be different. Now, we're going to talk about the Desmos part in a minute, which is really just the most important part, but I'm still going to go through this by hand so you can hopefully learn something as we go through. Now, the first thing we would do is distribute through. So this is going to give us 77x minus 77k is equal to 77y plus 77k. Now, you could put this equation into y equals mx plus b form, figure out what the slope is, figure out what the intercept is, but you're going to have to go through and check all of these, putting them all into y equals mx plus b form, and often that's where students will make a mistake. So one of the things that we also can do is we can put it into the like form, which is our ax plus by equals c standard form. So we're simply going to add over the 77k and we're going to subtract over the 77y. So once we get there, we're going to see 77x minus 77y is equal to 154k. Now, the reason we're doing this is if everything is in the same form, we actually have a few little tricks to identify the slope and y-intercept very quickly. If stuff is in ax plus by equals c form, the slope is technically negative a over b, but if we're looking at both equations in the standard form, if the slopes are going to be the same, the ratio of our x coefficients to our y coefficients is going to be the same because that's what's determining the slope. So if we want our slopes to be the same, which we do for no solutions, we want the a over b to be the same as a over b when it's in the standard form. Now we want our intercepts to be different. Our intercepts are always going to be determined by the c over b. So what we want here is we do not want the c over b to be equal because we need to have a different intercept. So this lets us look at this now, once we understand this, in a relatively quick way. So we can simply do 77 over negative 77, which is going to give us negative 1. So if our slopes are going to be the same, the ratio of that a to b has to be negative 1. A and b are both out because those are going to be positive 1. Now we need our intercepts to be different. Our intercept is going to be the 154k over the negative 77, which is the same as negative 2k. So what we know is when we're looking at this and we're doing our 22k divided by negative 11, well, that would give us negative 2k. So this would give us infinite solutions, but with c, the 11k over the negative 11 will give us negative 1k. So that is going to give us a different y-intercept. Therefore, we're going to have no solutions. Now, that's all really, really tricky. So we're going to jump over to Desmos and talk about how we can actually do this way more easily. We're going to go through the way easier way to do this in Desmos. So the first thing we're simply going to do is enter in our first expression. Most of this question hinges around our conceptual understanding of what we're looking for, and we're going to put a slider in for the variable. It's equal to that 77y plus 77k. Now, the value that we're going to pick is not going to affect the question at all. It's just going to move the equation. So we'll just leave it there. But here we can see that C is our correct answer because if we do 11x minus 11y equals 11k, we can simply see that these two lines are running in parallel. And you can use this for any of these types of questions. If you're looking for no real solutions, if they give you two equations, simply graph them. There's no reason to open up the door to doing all the difficult work we did, but that's how you can see that C is correct. Now, if you're looking for more practice with difficult questions like these and also learning some really helpful Desmos tricks like this, definitely check out our advanced math courses. Now, the next thing you're going to see on your test are notes questions. And of course, these show up every single test. But the reason I wanted to include this in the prediction video is with the release of the 4 new Blue Book tests, the SAT has signaled a shift towards how they're going to be testing these and the frequency of this shift. Now, we already got a little bit of a hint in the past year with what students were seeing on the real test that they were assessing the accuracy of the notes, because previously you could just find one answer choice would be answering the question, but now we're seeing a whole lot more of this. So this is something you should really be cautious of on test day. Once you find answer choices that feel like they're answering the question, placing Einstein's argument within its historical context, make sure you're being really, really careful that it's actually accurate given the notes that you're given here. because we've seen a lot more of these on these newer practice tests, so I anticipate you're going to see a lot more of this on test day. Here, the most common wrong answer does a really good job of illustrating this. The 1927 Solvay Conference on Physics, placing it in context, Einstein disagreed with Bohr's argument that subatomic entities like electrons had a reality independent of observation. Well, that was Einstein's argument. So although this feels like it's answering the question, it's not accurate given the notes. A here, during the dawn of quantum theory, Einstein maintained the independent reality of subatomic entities. This is all correct. Although Bohr's opposing interpretation would become the widely accepted view, that's also correct, placing it in the context here. Doesn't put Einstein's argument within any sort of context here. That's how we can see that A is our correct answer, but be very, very cautious of these on test day, or they're going to be quite easy to miss. Now, the next thing you're going to see is the other type of solution question we can see on the test, and these are discriminant questions. These are super, super common. Now, the way that you're going to spot you're dealing with this is we're going to see a quadratic, and it's going to talk about the number or type of solutions. And that means you want to use the discriminant, which is the part of our quadratic formula, which is b squared minus 4ac. And in this case, if we have one distinct real solution, it has to be equal to 0. Now, what we always want to do when we get questions like this with the system of equations having one real solution, so we want to start by setting them both as y equals. So that means we're going to subtract over the k here, and we're going to add over the k here. That is going to give us that y is equal to x plus 26 minus k, and y is equal to x squared minus 5x plus k. Now we can set these two equations equal to each other because we ultimately need to get this all equal to 0 so we can identify our a, b, and c values. So we're going to have our x plus 26 minus k is equal to the x squared minus 5x plus k. Now we can subtract over the x, the 26, and we're going to add over the k. That is going to give us that 0 is equal to x squared minus 6x minus 26 plus 2k. And this is where a lot of these questions get a little tricky for students. We want to identify that our a value is 1, our b value is negative 6, and our c value is the negative 26 plus 2k. But now we can simply plug this in. So we're going to have our negative 6 squared minus 4 times 1 times the negative 26 plus 2k, and this is all going to be set equal to 0. And now we just need to solve for k from here. So this is going to give us that 36 minus the 4 times the 1, and then we're going to distribute that to all of that. So this is going to give us plus 104, and then minus 8k is equal to 0. So now we can add over that 8k. I'm going to jump up here as I'm running out of space. But this is going to give us that 140 is equal to 8k, and now we can divide both sides by 8. And when we do so, we're going to find our correct answer of k is equal to 17.5. Now, two other conditions you can see with these discriminant rules that we want to be aware of. If you see more than one solution, that means b squared minus 4ac is greater than 0. And if you see no real solutions, that means you're going to set your b squared minus 4ac is less than 0. Now, the next sort of thing you're going to see is some sort of inscribed shape question. There's a ton of these. We have a lot of varieties across our advanced math courses. But here we see a circle that's inscribed inside of squared a, b, c, d. Segment AC is the diagonal of the square, and its length is 30 centimeters. What is the radius of the circle in centimeters? Now, few things we want to generally speaking understand with these inscribed questions. Number one, make sure you draw them out or it's going to be really hard to visualize what's happening. But number two, oftentimes these inscribed shape questions in some way have to deal with 30, 60, 90 or 45, 45, 90 triangles. And once I start seeing root 2s and answer choices, that would kind of give me an indication I may be thinking about that. We also want to think if we create a diagonal, it's going to create a 45, 45, 90 triangle. So if we're thinking about those in terms of those 45, 45, 90 proportions, we're going to have x, x, and x root 2. So the first thing we're kind of looking at here is if we figure out what the whole side length is of one of these squares, that will be equivalent to the diameter of the circle, and then we can simply take half of that to find the radius. So we need to figure out what x is. So we therefore can say 30 is equal to x root 2. Therefore, x is equal to 30 over root 2. And now we need to rationalize this. So we're going to multiply this by root 2 over root 2. That's going to give us that x is equal to 30 root 2 over 2, or x is equal to 15 root 2. And so now from here, we know that the entire side length, or the diameter, is equal to 15 root 2. So therefore, we know the diameter is going to be 2 times as big as the radius. So if we want to know what the radius is, we simply need to take our 15 root 2 and divide it by 2, and that's how we can find that A is our correct answer. Now, the next thing you're going to see on your SAT are sentence structure questions, and these make up a pretty high percent of the grammar questions you're going to see, these conventions of standard English questions. What they're really testing you on is how to spot independent and dependent clauses and understanding the proper rules around joining these. A lot of students just try to do these based off what feels right or sounds right, and the SAT is often going to trip you up, especially as we get to more complex versions of these. So here we can see Gitlin's use of the term reference TV studios' practice of repackaging successful narrative formulas is new content. Well, all the way up to content, we have an independent clause. Now if we look afterwards, in that era, even shows that varied only slightly from other shows still attracted sizable audiences. That's also an independent clause. So the only one that could possibly work is B. We have 2 independent clauses. This is really just a little introductory phrase or extra information at the front of it. But if you're not familiar with independent clauses and dependent clauses, I'm not going to run through that in this video because I can help you learn those rules a whole lot more formally and thoroughly in the free trial to my Ultimate SAT course. You don't need any credit cards. It's really completely free, but we're going to teach you how to spot these different clauses, give you a lot of practice around spotting them, talk about a lot of the issues students have with these types of questions, and then go over all the rules around connecting them and give you quite a bit more practice with those. So make sure you check that out if you aren't familiar with these rules, because it really can make a meaningful difference in your score. You can also check out some other helpful stuff in the free trial. Now, the next thing you're going to see on your SAT is some form of what we can think of as an advanced unit conversion question. This is about as difficult as these can get, but if we actually remember a few key steps, almost anybody can get these right, and they often show up towards the very end of that second harder math module. So these are graded as super, super difficult questions. But the thing you're looking for with these is any sort of squared units. This is kind of what makes these advanced. So that's where the trap is going to lay. An object's speed is increasing at a rate of 8.4 meters per second squared. So per is kind of a code word for divide. So we can do 8.4 meters over, we'll do 1 second squared. What is the rate in miles per hour squared rounded to the nearest integer? Well, the first thing is we want to go from meters to miles. Now, whenever we're dealing with unit conversion, you can always tell you've set it up correctly if you're able to cross cancel them. So we're going to put our 1,609 meters on the denominator, and we'll put our 1 mile on the numerator. At this point here, we would be in miles per second squared, but we want to get into mile per hour squared. So now we have to start using our time conversions. So what we know is there's 60 seconds in 1 minute, and then, because we want to get all the way to hours, we know there's 60 minutes in 1 hour. But currently we haven't set this up correctly because we had second squared. So that means we need to square this conversion factor. So our second squared are properly canceling out. Then we're going to be left with minutes squared. And we need to square this conversion factor so we're getting into hours squared. That's the whole trap to these questions. If you see squared units, you need to square your conversion factor. If you see cubed units, you need to cube your conversion factor. So really what we are doing here is 8.4 divided by 1,609 times 60 squared times 60 squared. And that's going to give us our correct answer here. So we're going to go ahead and pop that into the calculator. And then this is going to give us a nice big number, 67,659. And since we have like 0.41 rounded to the nearest integer, this is going to give us our correct answer of 67,659. Just be really careful with those squared or cubed units. But if you remember, we always have to cross cancel our units. You really can set these up because even if you aren't sure about which place they should be going, you can always make sure our meters are canceling out, our seconds squared are canceling out, and then our minutes squared are going to be canceling out, and we're going to be left with our miles per hour squared, and that's going to let you see that you've solved it properly. Now, the next thing you're going to see on your SAT are some challenging scientific passages in that second reading and writing module. So we're going to take a look at one from one of our practice tests. This is about a medium hard one from one of our practice tests. So pause the video, read through, see if you can find the right answer. Now, for these support or weaken the claim questions, whether it's a hypothesis, a claim, an argument, whatever it is, the first thing is we're reading through, we want to make sure we identify that. So here, it's going to always be really easy to find, right? They hypothesize that since prey body size mediates predation risk, there will be an inverse relationship between body size and reproductive investment due to predation pressure. Now, the reason they're giving us this hypothesis is they're now saying, we want to see how you can properly relate this back to the rest of the information that we've given you in the passage. So once we see this, it's kind of a filtering statement we want to read through. So we see, I'm going to do this just in shorthand, we had Eryctolagus caniculus weighed 1.5 kilograms. And one thing I've had a lot of success with first students is starting to take shorthand notes with these. And then we had Lepus europaeus, we'll just do LE, weighs 4 kilograms. Well, now, what's the relationship that we should see here? If there's an inverse relationship between body size and reproductive investment, that means the smaller ones should have, we'll just do this as our reproductive investment, they should have a greater reproductive investment than the bigger ones. They should have comparatively less. Once we've done that, we're able to unpack these passages and find the right answer a lot more easily. And that's exactly what D says. Eryctolagus caniculus were found to have a litter frequencies of at least 4 per year, and Lepus europaeus had a maximum litter frequency of 3 per year. This is showing us, right, our smaller one is having the greater reproductive investment, having litters, having babies, than the bigger one. That's how we can see that D is correct. Now, there's a handful of different common types of wrong answer choices, but in these scientific passages, the most common one you're going to see and the most common one that students mess up on is opposite of the passage. They're going to totally flip it. So it's going to be stuff that would be weakening the hypothesis. If we look at A here, when DeVincenti and colleagues monitored litter frequency of leopardized species, they found that leopardized species larger than Lepus europaeus have a greater litter frequency than those that are smaller of Eryctolagus caniculus. This is backwards. We would want to see the reverse of that. B, many leopardized species smaller than Lepus europaeus have litter frequencies greater than 5 per year. That would be totally fine. But none smaller than Eryctolagus caniculus did. This becomes an outside of the passage answer. We have no evidence to support this. This could be true, but there's nothing in the passage and there's nothing in that hypothesis that places some sort of limit on the size and the relationship. Eryctolagus caniculus had a litter frequency greater than Lepus europaeus did. That would be all good so far. And leopardized species larger than Lepus europaeus had an even greater litter frequency. Well, that's opposite of the passage because, once again, the smaller ones should have greater reproductive investment than the bigger ones. So that's one thing you want to watch out for. Now, if you want a lot more practice with questions of this difficulty and beyond, and some practice tests that are really accurate and reflective of the difficulty you're going to see on test day, strongly recommend signing up for our Ultimate SAT course. We have 4 full practice tests, and we're going to have at least a 5th uploaded before the March SAT. Now, the last thing you're going to see on your test, then we're talking about some general recommendations for helping you better prepare yourself as we're closing into test day, are tricky transition questions. These are going to be super, super easy to spot because you're going to see transitions and you're going to start seeing answer choices with like comma transition semicolon or semicolon transition comma. And with these, we do need to understand those independent and dependent clause rules we talked through earlier. So if you aren't familiar with those, please check those out in the free trial. But the big challenge is figuring out whether we should pick stuff like C or D or whether we should pick stuff like B. A is always wrong with these questions. The first thing you want to do, though, is ignore the transition and check for the type of clauses. So they were not the first in England to adopt the literary modes of classical antiquity. This is an independent clause. Some of the most prominent figures of the early Renaissance period were also influenced by ancient Greek and Roman literature. This is also an independent clause. So at this point, we already know you don't want to pick A with that single comma, but we cannot do B because these are not properly joining our independent clauses together. Now, we get stuck between C and D. Now, if you are stuck on one of these on your test on Saturday, lean towards this answer. It's correct about 75-80% of the time. But the really easy trick you can use to check this is if this structure is correct, you can place the transition back at the front of this sentence. And then when you read through from the first to the second sentence, that transition should make sense. So here we should see a contrast between sentence 1 and sentence 2. During the English neoclassical period, many writers imitated the epic poetry and satires of ancient Greece and Rome. However, they were not the first in England to adopt the literary modes of classical antiquity. There is a nice contrast there. That's how we can see that C is correct. If D was correct, we'd have to see a contrast between sentence 2 and sentence 3, but we are not getting a contrast between those two. So now we're going to talk a little bit about just some general recommendations heading into test day. If you guys do have any questions about anything in the video here or otherwise, please drop them in the comments below. But we're going to talk through a few different scenarios. The first is going to be for those of you who are cramming and haven't done as good of a job of prepping as you would like to. The second is going to be for those of you who are just really struggling on the second harder math module. And the third is going to be for those of you with a little more time on your hand, whether you want some extra practice tests or you want a little bit more thorough prep. So to start with the first situation, if you're watching this video, you're within a week or a week and a half or 2 weeks and the panic has set in and you're just looking to improve on the easiest to learn concepts that show up every single SAT, I strongly recommend checking out our SAT crash course. Students have loved it and it is really just created for your situation. So we're not diving into a lot of content that you're not so likely to see. Now, the second situation, which is super common for a lot of students, is if you feel like you're doing pretty well in the math, but you're just struggling on that second harder math module, I strongly recommend checking out one of our advanced math courses. We now have 2 volumes. They each have 150 questions. It's going to really just be focused on those types of questions that you're going to see from about 16 to 22 in that second harder math module. And the kind of secret to most of the second harder math module stuff is you just need to understand how to start it or the tricks around those questions. Really similar to that advanced unit conversion question we looked at earlier. Once you understand the steps and process and you get some practice with different varieties, it's not nearly as hard on test day. Now, the last group is going to be for those of you who want a little more practice with everything. So if you want access to our practice tests, you'll also get access to one of our advanced math courses in the first month, all of our writing and reading courses, and you really want a lot more comprehensive prep, I strongly recommend signing up for our Ultimate SAT course. It covers everything A to Z. You get all those resources. So if you have more time on your hands, or you just want to focus on advanced math and also get access to those 4 practice tests in the 5th, which is coming soon, I strongly recommend checking that out because it's going to hopefully really make a big difference in your score as you're heading into test day as long as you have the time on your hands. As always, if you guys have any questions, drop them in the comments below. I really hope this video helped you out and is going to help you pick up some extra points on test day.